Hey, welcome to Math with Patrick. Today is January 11th, and we're solving the 11th problem from this Daily Epsilon calendar. So let's hop right on into it. We are solving for x. We already know the answer is 11, but it's important for these problems to prove why this is the case. The first equation we're given is 3 sine theta plus 4 cosine theta is equal to 5. And I know that with one equation and one variable, usually you can solve for this one. And once we know what that theta is, I can tell that if we plug it into these ones and add it all up, we should get 11 as our answer. Now, that's easier said than done. So let's try some stuff out. With this first equation, I'm supposed to be able to find what theta is. And I see a 3 and a 4 and a 5. And this kind of makes me think of that 3, 4, 5 Pythagorean triple. Not really sure how this is supposed to help out, but maybe there are some things I could try. I at least know that sine and cosine, their range of values go from -1 to 1 at most. And so both this sine part and this cosine part need to be working together to create a 5. And for example, what I mean by that is if I didn't have the sine part right here, 4 times 1, the maximum value, will not get me to 5. So I need both of these parts to be positive and working together to sum to a 5. That tells me I'm in the first quadrant of my unit circle, because here is where sine and cosine are both positive. And I don't really have any other leads besides trying some stuff out with that 3, 4, 5 triangle. So since we're in the first quadrant, I know that I could potentially place a theta here, and that would represent some angle in the first quadrant. And well, if I take the sine of this angle, sine of theta, that's going to be opposite over hypotenuse, so 3/5. And cosine of theta is going to be adjacent over hypotenuse, or 4/5. I guess I could try it out. If I do some substitution here, I can replace the sine of theta with 3/5. And I can replace this cosine theta with 4/5. And I'm checking to see if this is equal to 5. This is 9/5 plus 16/5 is equal to 5. I'm still not quite sure, but actually now I am. 9 plus 16 is 25. Divided by 5 is 5. This is something I know for sure. So if this equation is true, then this equation is true, then this equation is also true. So it looks like I'm allowed to do the substitution. Subbing in these values into this equation made it true. So I guess my theta is this one from this 3, 4, 5 triangle. That was a nice discovery. I cleaned up my thoughts a little bit. Here I'm just writing out my whole idea that sine and cosine need to be positive, so I'm somewhere in that first quadrant. In other words, my theta, or my angle, is somewhere between 0 and pi over 2. 0 is here, and pi over 2 is the same thing as 90 degrees. Then I wrote out that I just kind of investigated this 3, 4, 5 triangle, and by doing some substitution, I verified that this is my theta right here that satisfies this first equation. So this theta also will work for this equation here. That means 5 sine theta, I'm just writing out the whole equation now, plus 5 cosine theta plus 3 cotangent theta is equal to x. I already know that sine of theta is 3/5. So 5 times 3/5. 5 times, and then cosine was 4/5. 4/5 plus 3 times, and then cotangent. Let's see, cotangent is the same as the reciprocal, or the flip, of tangent. Tangent from SOHCAHTOA, let's see, so tangent is opposite over adjacent. So I should flip that to get cotangent. So adjacent over opposite is 4/3, and this should all be equal to x. So let's just solve this fraction equation. I get a 15/5 plus a 20/5 plus a 12/3 equals x. This is just a 3. This is a 4, and that's a 4 equals x. Great. 3 plus 4 plus 4 is 11. Nice. All right. So I got a little bit lucky with that guess about comparing it to a 3, 4, 5 triangle, but after finding what this theta was and plugging it in, I have shown that x is indeed 11. Thanks for coming along with this journey, and I hope you enjoyed the solution. I will see you in the next episode. All right, bye-bye.